This time at CMU for me was very, very special. And I think you've heard from Lee, and you'll hear from other people about the type of collaboration and so forth. And what I think we need to talk about is how special Raj is as a boss, and a special person that makes an environment that we had possible. And also his creativity and his vision is inspiring. And my whole academic career has been inspired by the work that I did in those 5 years, and with Raj's, the experiences I had about how to manage and how to do research, the multi-pronged research focus that you had, and all these ideas I really took to heart and really affected my career. And so I really need to thank you, Raj, for how special that experience was for me. And by the way, I go back with Raj a little bit earlier than earlier. In 1967, the summer of 67, I was my first year of graduate work at Stanford. And I actually worked with Raj at the AI lab. And for some reason it didn't work out. I had a graduate fellowship, and I just went back to my research. And I did a thesis in computer architecture, parallel processing, and distributed processing. And I was going to go into industry, and Raj gives me a call and says, why don't you come out and interview for a faculty position at CMU, which I didn't get. But later on, Raj maybe got the money for this big project. He said, why don't you come here and work on a parallel processing version of the speech understanding system? Because I think early on, Raj, even before that, understood how important processing speed was, and getting more parallelism, getting more speed into the system. And that was one way. And there was a whole new effort called CMP. That's right. And unfortunately, the software was very buggy, and it didn't work out. And then we were thinking about how to move on from the hearsay effort that you're seeing, that figure that Lee showed, and out of that came the effort to do hearsay 2. And one of the features which we worked on, and which later on led me to the whole direction of parallel processing, distributed versions of hearsay 2 and multi-agent systems, was that we should allow for parallelism in the hearsay architecture, so that the knowledge sources could contribute concurrently. But that's a history of it. I want to say that hearsay was a successful project, but it got lost as a architecture for speech. And I'd like to examine that a little bit and see whether that was let's go back. Wait a second. Okay, I need one more. Let's see. I'm having problems. Okay.
Up arrow, Victor.
Up arrow. Okay. All right. So this is just for people who are not familiar. This is the hearsay 2 architecture, the blackboard, the knowledge sources, the multi-level structure, the control structure for deciding how to run knowledge sources, which operators, which knowledge sources to apply next. And the opportunity that gave us was the ability to have sophisticated control. We could go bottom up, middle out, top down. We could use a variety of different knowledge perspectives, diverse knowledge, as Lee talked about error correction in that, approximate and precise knowledge. and the incremental and dynamic knowledge interaction as the problem was emerging. So that was the architecture we used. When we actually built the speech system, not all those features, the up arrow, down arrow. Not all those features were used, but we'll get back to that in a second. One of the things that happened was the Harpy system, which you'll hear about, surpassed, and that was done here, surpassed the performance of hearsay, and it became the dominant approach for a while here as a way of doing speech. And before I left, or just after I left, I worked with Lee and a graduate student, John Laird, who's now become famous, on trying to understand why Harpy versus Hearsay 2, why the performance difference. And I was talking with Rick, and we had talked about this when the project was going on, and we had this idea that Harpy had more extensive search because all the precompiled knowledge and the simpler search mechanism would allow it to look further and deeper into alternative hypotheses so you could compare things with more knowledge. And we mapped the hearsay search process into the same search space as Harpy because, in fact, we were working with the same databases, we had the same experimental data, and we did this comparison. And what was surprising is that the search spaces, when you looked at it from that perspective, were very similar. And it wasn't our hypothesis that Harpy did a more extensive search. And in fact, the only significant difference we found is that Harpy did a better view on evaluation of a particular hypothesis, and that was because of the co-articulation knowledge that it used. We used some rough co-articulation knowledge, didn't spend as much time as we should have on evaluating things based on co-articulation. And so it's this whole idea that how you search a space can be very different. Do you use simple knowledge and simple structures versus more complex control? I'm arguing that either or. It's not a yes-no situation that always... I just wanted to bring that intellectually up to you. All right. I just wanted to say that I did do further work in speech while I was at UMass, and this was on household sounds, doorbell ringing, etc., where you had co-articulation, but the idea was multiple sounds could co-occur, and you had to recognize the multiple sounds, the doorbell ringing, the phone going on, etc. And we developed an advanced architecture to do this, a blackboard architecture, but here we used more of a planning architecture, and we used discrepancy detection diagnosis capabilities about recognizing when the system wasn't right, because in fact, when you have multiple sounds, they may not be processed correctly, and you have to go back and reprocess the data with different parameters with the Fourier transform. So we could recognize when things weren't going well, go back and do a formal diagnosis, say, why could that have hurt? What signals didn't we hear in the thing? Can we change the parameters? So in fact, we did realize this bottom-up, top-down approach in a more sophisticated way than we did earlier. And it was the first time that this type of application was done. So the hearsay architecture did have some life in this domain. And finally, let me say that is this whole idea of dynamic separation and interaction at runtime versus precompiled, is that still an idea given deep learning, given reinforcement, deep reinforcement learning, et cetera? Is it still worthwhile to think about doing problem solving in a more dynamic way. And I would argue that this architecture does have a role. Even with deep learning, we can learn the components. Using deep learning, we can learn the control strategy through deep learning and then integrate things dynamically. And in fact, I talked with one of my former students who's an expert in deep learning, and he pointed me to this work on expert sparse learning, which is exactly breaking the learning into separate components. And so the ideas of hearsay architecture, I think the Blackboard architecture and that thing that Lee originally worked on and Raj defined in something really has application now, I think. So,
Thank you.
okay, great.